Welcome to another video on chemistry, and in this video we're going to be discussing reaction yield. So a couple of things to consider as we move along. These are the terms that we're going to be highlighting in this video. I'm going to be giving you the definition of them, and then we're going to apply those to an actual chemistry problem. So theoretical yield, actual experimental yield, and percent yield. So keep in mind how these terms are alike, how are they different, and then how do they combine to eventually give us our final goal of gaining a percent yield in a reaction. So a theoretical yield is the amount of product that would result in all the limiting reagent if all the limiting reagent reacted. Okay, so this would be a perfect scenario where every single atom in your reaction side actually combined to make something new, some new product. So this is the ideal perfect condition or the ideal perfect reaction if that would occur. And this is predicted by your balanced equation. Okay, and I'll show you how that works exactly as we work one of these problems out. So in the real world though, you're not going to get 100% of all your atoms reacting in a particular reaction. You're only going to get some of them. So you're going to get what's called an actual or experimental yield. And this is obtained from the actual reaction or obtained experimentally. Okay? So you would use your theoretical yield, which is the perfect condition if everything combined, and then you would use your experimental where you get your actual results from your experiment and you compare them to get a percent yield. You would compare them in a proportion of actual yield to theoretical yield, and this is what it looks like. So you have your actual yield divided by your theoretical yield times 100 to get a percent yield. So let's actually work out a problem so you can see how this looks. So in a certain industrial operation, you have 3.54 times 10 to the 7 grams of titanium chloride. They are reacted with 1.3 times 10 to the 7 grams of magnesium. So this is your experiment. You have these two reactants, and these are the specific amounts of each of these reactants you have. Okay? And you want to calculate the theoretical yield of titanium in grams based off of what you've been given in your reaction. And then you want to use that to find a percent yield if you actually yielded 7.01 times 10 to the 7 grams of titanium. Okay, so let's go ahead and start off. So here we have our givens. So one of these is our limiting reagent. Our reaction is limited by one of these two reactants, and we need to find out which one. You'll notice that they're both in grams, so I need to change these, convert these units of grams into moles. So which one makes the lowest amount of moles? Okay, 3.54 grams to the 7 grams of titanium chloride, or 1.13 to the 7 grams of magnesium. So I'm going to convert both of them into moles. So I'm first going to convert titanium chloride into moles of chloride. And to do that, I need to find the molar mass of titanium chloride, which I have right here. If you don't remember how to get molar mass, I do have a video that discusses that, so feel free to watch that. So you'll notice here that I have grams of titanium chloride, and that unit will be canceled out by my molar mass of titanium chloride, which gives me moles of titanium chloride. So now I have a unit that I want. I have moles of titanium chloride. So the next thing I want to find out is how many moles of titanium I make. In order to do that, I need to use my mole ratio from the balanced equation. So if I look at my balanced equation, I notice that I have 1 mole. So for 1 mole of titanium chloride, I yield 1 mole of titanium. So it's a 1-to-1 ratio. Pretty simple. So at this point now that I have my ideal or my desired unit, which is moles of titanium, I can just do the simple arithmetic, and I find 1.87 times 10 to the 5th moles of titanium. Okay, so let's now find how many moles of titanium I make from 1.13 to the 7 grams of magnesium. Magnesium. So again, I need to find the molar mass of magnesium. So I go to the periodic table and find that it's 24.31 grams per 1 mole. And now that I have moles of magnesium, I need to find how many moles of titanium. And the connection that I have from magnesium to titanium based off of my my balanced equation is for every 2 moles of magnesium, I produce 1 mole of titanium. Okay, so this is the conversion factor that I need to get from moles of magnesium to moles of titanium. And I find that I can make 2.23 to the 5th moles of titanium. And when I compare the two amounts, I notice that titanium chloride produces the least amount. That means I am limited. This reaction is limited by the amount of titanium chloride that I have. So that is my limiting reagent. Okay, so this is the quantity that I actually need to find my theoretical yield. 1.87 times 10 to the 5th moles of titanium. Okay, I find the molar mass of titanium because again I want to find in grams. That eliminates my unit of moles that I don't need, and that gives me grams of titanium. Okay, so I multiply 1.87 times 10 to the 5th by 47.88, and I get 8.95 times 10 to the 6th grams of titanium. And this is the theoretical yield in grams. Okay, so part B. Okay, I've finished part A. This is my theoretical yield. If this reaction were to go perfect and every single atom of titanium chloride and magnesium were to combine and react, then this is exactly how much I would get in the perfect 100% reaction. So this experiment was conducted, and part B says that 7.01 times 10 to the 7th grams of titanium were actually obtained. And you'll notice that 7.01 is a little bit less than 8.95 times 10 to the 6th. So that's a problem because I have an actual yield and I have a theoretical yield. So you see here I have my actual yield divided by my theoretical yield, and this is the decimal that I get times 100. I get 88.4 grams. Okay, I'm sorry, 88.4% of yield. So that means when I actually performed this experiment, I achieved an 88.4% yield from my theoretical. That's pretty good actually. Okay, and that's how you work out a percent yield problem. Keep in mind, so number one, theoretical yield is the yield that you calculate using the balanced equation. Okay, that's the ideal equation when everything combines. And the actual yield is the yield obtained by carrying out the reaction or the experiment. This is the real world results that you would get. And then you would use both of those. A percent yield is determined as a determination of how much was experimentally obtained compared to how much was supposed to be theoretically obtained. So you compare those two amounts using this equation, okay, and you get what's called a reaction yield, a percent yield. All right, that does it for this this section. Good luck in your studying.